Good afternoon, good morning, maybe even good evening, depending on when you're actually watching this video. And maybe you're watching it for your second time, because maybe you should watch it for your second time. Because I'm just about to cover about half of Unit 4. And that's right, we're going to cover half of it so that we can go ahead and explore the rest of it out with our hands and our feet in Point Lobos and down on the baseball field and other places around our local area. And that's right, folks, we're talking earth science. We're talking about plates moving. We're talking about earthquakes. That's right. Maybe we're a little bit late. We had a drill, we had an actual one, and now we're going to actually learn what just happened and what is going to be happening in the future. It's inevitable, folks. There are going to be earthquakes. Plates are moving. I apologize in advance for any sounds in the background. That is just the reality of me, unfortunately, not being here today because I got a sick kid who's trying to do away with some sickness in a bathtub right now, and he's making sounds as he does away with that sickness. So, anyways, let's go ahead and begin. What you're going to be seeing right now, hopefully in front of you, and if not, you need to pause this video, is you're going to see, as I switch to it, you're going to see the Unit 4 packet, which should have already been given to you. And Unit 4 is all about geology, and that includes layers of the Earth, how the Earth changes, aka geomorphology, the rock cycle, rocks themselves, plates, plate tectonics, and also soil. And that'll take us right into our ag unit, which is arguably many people's favorite units. So here we are on the Unit 4 packet, which you should have been given. And if you were not given, I'm posting it on Google Classroom for you to print out. But let's get going. And just so you know, before I get started, we're going to do much of this more in an engaging fashion, but at least today, you're going to have the first 4 pages of notes, okay? Which is great because we're biting off that bullet. We got the content, and now we're heading home. All right, so the Earth is divided, as you probably heard, into 4 layers. The first layer, the inner layer right here, is the core. The core is solid, and it's because it's high pressure. It's got very high pressure. It's really hot. It's got a lot of nuclear activity, which is what makes it so hot, going on in it. Nuclear activity. And it is mostly composed of iron and nickel. Fe, which is iron, and nickel. Those are the main elements. Then we have the outer core, which is pretty large, and we'll look at the relative sizes later on in class. But the outer core is hot, but it's molten, and it's, again, mostly iron. And it's molten because it doesn't have quite the amount of pressure of the inner core, mostly Fe. Again, that stands for iron. And then we have the mantle, okay? And the mantle is important. It has a fudge like consistency depending on the layer of the mantle. It is, what should I say? Fudge like, it is partially solid. We'll use some other words to describe it later on, but the important thing about the mantle is this is where convection takes place. And convection is where hot things rise and cool things fall, and that creates this convection currents, and these convection currents are what move our plates on the crust, which the crust is the outermost layer. And the crust is all solid. And we'll talk more about that in the next objective, aka right now. So the crust there's oceanic crust, and this oceanic crust right here is more dense. And that's important in one of our future discussions. And then there's the continental crust, which this means it's not under the ocean, continental crust. And the continental crust is less dense. And again, this will come into play further. Now, the mantle itself is represented in this diagram right here, which these next three layers are actually all showing the mantle. And there's the upper mantle, which is rigid, and that means solid. And the upper mantle is solid, and the crust is solid. And so the upper mantle and the crust are collectively called the lithosphere. So lithosphere is both crust and upper, I'm going to call it upper mantle. Basically, it's the solid layer of the earth. And then there's the next layer of the mantle, which I just have this little box, which I'm going to zoom in, but if you need some more room, go for it. It's called the asthenosphere. And this is like a smooth layer of mostly liquid. This is kind of that fudge-like, semi-rigid, but a little bit more slippery layer. This is the layer at which the plates float on. Plates float on. And again, this is one of my favorite words. I'd encourage you to say it. It's called the asthenosphere. All right. And so that's part of the upper mantle as well. So both this upper rigid layer and the flowing layer are part of the asthenosphere. And the majority of the mantle is what we refer to as lower mantle, and that's that semi-rigid layer of the mantle, the fudge-like consistency where convection is occurring. So why does this all matter? Well, all of this adds up to how our Earth is actually moving. And our Earth is moving in this theory called plate tectonics, where the Earth is broken up into these different, specifically the lithosphere, which is a little bit of mantle, a little bit of crust, broken up into these plates, which are these sections of solid Earth, which move. And they move because things are moving below it. Specifically, convection is happening in the mantle below it. So let me just draw that whole convection process out. Again, next class we'll actually look at that. And convection is happening because the core of the Earth is hot. It's hot down here. And so here we have hot stuff rising. Okay. And then we have hot stuff coming to the surface, and then it cools off a little bit, and then we have cool stuff falling. And that whole process creates these currents, and these currents move the Earth, as you would probably predict. And they move it in sections, and those sections are called plates. And so let's go ahead and look at the plates here. There's a lot of plates in the Earth, and there's some particular areas that you want to be familiar with. So first of all, let's just talk about some of our major plates. So the Pacific Plate, this whole thing right here, this whole thing that I'm shading in right now, this is all the Pacific Plate. And that is the largest plate. And the Pacific Plate is also the plate that we are on. We are on the Pacific Plate. Then there's the North American Plate, which is where most of North America is on, probably not surprisingly, but we break off from North America right along here. I'm going to go ahead and just pause real quick as I ask the family to just quiet down. Hey, you guys, everybody can hear you. Can you guys quiet down just a little bit? Thank you. Sorry. Okay. All right, so we got our North American plate right here, which is where most of North America is on. There's also some boundaries right here in between the North American and the Eurasian plate, which you're going to want to pay close attention to. And then also, I'll just point this out right here. The whole boundary of the the Pacific plate is called the Ring of Fire. And that's a concept that comes up over and over again. Other plates to notice. So we have the North American plate. That's where most of North America's on. North American plate. And then we also have the Juan de Fuca plate, which it's a little one, but it's subducting right underneath the North American plate, creating an important mountain range north of us. And so I feel like it's a pretty important plate to know. So, but the main thing to know about plates are the type of boundaries, okay? And then what types of geologic formations form at these boundaries. So, first type of plate boundary is a divergent. And like I have it written right here, divergent boundary is where new crust is generated. So new crust is generated in a divergent boundary, and I'd encourage you to get your hands out where plates pull apart. So divergent boundary, plates are pulling apart. New crust is formed. This is where if it's under the seafloor spreading happens. Again, this is magma leaks through. It doesn't form a gigantic like volcano, but it just slowly leaks through and forms a type of rock called basalt, and that forms new crust. If it happens on land, then it forms like an actual trench, but careful, more forms like a gap in the land, but not so much a trench. The next type of boundary is a convergent. Okay. And so convergent, this is the most confusing one right here. If you have, there's three types of convergent boundaries. Okay. So here in a convergent boundary, you have two plates colliding. And those two plates can do a few different things. Okay. If it's continental crust colliding, that means it's two crusts of the same density colliding, and it forms something like the Himalaya Mountains. Or because they're both the same density, they just push each other up. And so it can form mountain ranges like the Himalayas. If it's an oceanic continental, that's what you're seeing in this picture right here. The oceanic crust, it undergoes subduction. So I'm going to go ahead and I'm going to write a word. It undergoes subduction. This is called a subduction zone. Subduction means it dives beneath because it's denser and it's older beneath the continental plate. And it dives beneath and then it melts. It melts. And then when it melts, it forms this volcano because all that melted crust comes back through. And that is an example right there of the Juan de Fuca is subducting underneath the North American plate. It's melting. That's melting. That's my fist right there. And then it's coming back up through as a volcano. And that's called the subduction zone. The process is called subduction. And there's an example of where an oceanic is converging with a continental. And the last thing you can have as far as convergent goes is you could have two oceanics form, right? And I'm going to look back at our map right here, and that's what's happening all along. Let me erase some things here, right? That's what's happening all along. Let me pick a different color, right? This area right here, where two oceanic plates are hitting each other, and the older oceanic plate is denser because it's been under water pressure a lot longer. So it actually goes underneath and it forms a trench. Okay. and then it goes underneath. It forms a trench, and then it melts and forms a volcano on the other side. So it forms trench and arc islands. So in oceanic continental, this forms a subduction volcano. And I'll go back to my purple here. And then an oceanic forms a trench plus arc islands. Arc islands, which form from those subduction volcanoes. Again, arc islands are just islands formed as subduction volcanoes. And then there's transform boundaries, which is where just two plates are slipping past each other. And that is like the North American and the Pacific plate right near us, the San Andreas Fault. San Andreas Fault. That is what's happening right there. They're just slipping past each other, not going away or towards each other, just slipping past each other. All right, moving right along. We're going to actually do this part to make sure you guys are understanding everything tomorrow. But let's make sure we understand what the terms erosion and weathering stand for. And so go ahead and pause and read those definitions. Erosion is actually moving rocks or soil from the surface of the earth and transporting it elsewhere, whereas weathering is just breaking rock into smaller pieces. And there's physical weathering, which is when rock is broken into smaller pieces by just like freezing and something expanding, causing it to break apart, or chemical weathering, where chemicals such as acid rain is actually like breaking rock apart, or biological weathering, where like a root or a living thing is actually breaking the rock apart. So again, take a moment and make sure you understand those three types of weathering, and then test yourself. Label each of these as erosion or one of the types of weathering. So that's right. Topsoil that took hundreds of years to form is washed away. That would be erosion. The roots of a plant crush sandstone boulder. That would be biological weathering. Acid rain dissolves limestone. That's right. That would be chemical weathering. And then rain wears down on a piece of jade. Let's see. Rain wears down on a piece of jade. That would just be the raindrops breaking apart the piece of jade. That would be physical weathering. And the last thing we'll cover today, and like I said, this is the majority of the unit. The rest of the time we'll use to explore this is the rock cycle. Okay, and then we'll do a little rock hunt tomorrow. And so for the rock cycle, what I want you guys to know is there's basically a few types of rock. There's a rock that we'll call sedimentary, which is just formed by layers upon layers. And then there's metamorphic rock. Metamorphic. And this is formed by heat and pressure. And then there is igneous, igneous, and this is formed from cooled lava. And there's both what we call extrusive and intrusive igneous. And extrusive means cooled on the surface, cooled on surface. And there's intrusive, which is cooled below the surface. And any rock can go to any other type of rock at any place in the cycle. Let's just go ahead and draw that out. So sedimentary rock can become igneous if it is subducted and melted, and it could turn into lava. Igneous could become metamorphic if it is further subducted, which means pushed below even more, subducted and undergoes heat and pressure. Okay. Sedimentary rock can become metamorphic rock by being subducted and pressurized and heated. And then any of these rocks, right? Igneous rock, hold on here. Any of these can go up to a mountain. I'll put up a mountain, right? Any of these can go up to a mountain and be uplifted. And that means pushed up by plates to form a mountain, right? Like we were talking about. And so here we have a mountain forming, and then weathering and erosion can form a sedimentary rock if a bunch of like igneous rocks or metamorphic rocks or even sedimentary rocks in that case are weathered and eroded, and they form particles, and then they can undergo cementation and compaction and form a sedimentary rock, right? So that can happen from any rock into a sedimentary rock. The key thing to think about there is like that's how a lot of ocean creatures, right? They give off their limestone exoskeletons and form this sedimentary rock here, but that's just one type of sedimentary rock. This is just the basics of the rock cycle and the stuff that I want you guys to have written down right now. But we will certainly kind of look at exceptions and other ways of which the rock cycle can happen. I think that's a good place to stop. Like I said, that was a good majority of the unit, at least the first half of the unit until we get to soil. And so watch and rewatch this video and come in with questions. And thank y'all for hanging with things. The next thing I'd like you to do is to learn a little bit about colony collapse disorder. And that is the next assignment on Google Classroom. And we will review and talk about things. Make sure you get in your permission slip because we are going on a field trip on Wednesday and Thursday, block day this week, to actually look at all this geology in action. Take care, everybody, and I will see you soon.